In the last two lectures, we have seen about the fundamentals of statistical modeling and how the models are planned, and how we are going to go about the distributions, the probability distributions, all that we have known. And then we have also known about the histogram and the normal distribution. And lastly, we have understood that normal distribution is basically dependent on its mean and the standard deviation, kurtosis and skewness. Today what we will do is that today we will be discussing about the mean, variance and the standard deviation, and how to go about it and include it in the statistical modeling part. Okay, so normal distribution is characterized by its mean. There are several types of mean, as you know. There is arithmetic mean, geometric mean, harmonic mean. In this case we will be considering the arithmetic mean or the simple average. Okay, now what is the fundamental thing that we need to take care here is that we are calculating the population mean, right? We are calculating the population mean by the formula summation xi upon n, where n is the number of observations and xi are the individual observation, right? These all things are known to us. Okay, now what we should remember here is that we do not know the population mean, right? We do not know the population mean. We have an idea about the population mean, and what we do is that we estimate the population mean from the sample mean. Okay, now this we should be always remembering that we are, which is given by x bar, right? So we are calculating or estimating the population mean with the help of the sample mean. Okay, now talking of the variance, if we can recall the normal distribution, this was the case and this was the mean. What we were doing basically is that in case of variance, we are trying to find out how far these data points are deviating from the mean. That's why it's the spread of data from mean. What we do is that variance is the mean of the square of the deviations from mean. Now it is a little bit confusing. We will break it. Okay, so variance is basically what we have individual observations, right? Individual xi observations, and then these are the deviations of individual observations from the mean. Okay, now we square it up and then we divide it by the number of observations and we sum it up. So this is the summation and the square of the deviations. Okay, these are the individual deviations, square of the deviation from the mean, and then we have divided it by the n, number of observations. This is the formula for calculating the population variance, right? This is the formula for calculating the population variance. But here we should remember that we do not know the population variance, but we estimate the population variance with the help of sample mean. Now this x bar is not the population mean. Remember this thing. Population mean is given by mu. Population mean, okay, we should also know that population mean is given by mu. So if we are calculating the population variance, in that case we have to include mu here, right? So this is the mu. But if we are calculating the population variance with the help of sample mean, then the formula will be xi minus x bar whole square by n minus 1. Here we are not dividing by n, but we are dividing it by n minus 1, because to compensate for the idea that we are estimating population variance from the sample mean, okay, and not from the population mean mu, because if we don't divide it by n minus 1, in that case if we divide it by n rather, it will underestimate the variance, right? So okay, now coming to the point of standard deviation, as you can see that the population variance is basically a square term, right? And in the x-axis we don't have that square term. In the x-axis we don't have the square term. So what we do is that we try to nullify the effect of square in the variance by taking square root. So square root is taken in the variance to have an idea of nullifying the effect of square, So standard deviation is equal to square root of variance. Okay, so square root of variance. Standard deviation is calculated to nullify the scale effect. Okay, in variance we square it up, so we take the square root to nullify the scale effect. Is it clear? Okay. Standard deviation is the standard representation of the variance. This is how the variance is represented, and it is calculated by the same formula, only we have to add a square root. So we are adding a square root in the variance formula, xi minus x bar, if we are calculating it from population sample mean, and in that case we divide it by n minus 1. Now if it is estimation of standard deviation. Now if we are calculating standard deviation, then it will be square root of xi minus mu whole square divided by n. In this case we will not divide by n minus 1. Remember the distinction. This is, we are using the sample mean x bar. Here we are using the population mean. This is calculating and this is estimating. Here, okay. Now what we will do is that we will see that if we take a sample and then we estimate the population mean and the sample mean, population variance and the sample variance, how these things go. Okay, now what we will do is that we will take the example in Excel and try to see how to calculate the population mean and the population variance and sample mean and sample variance, and how come these things are. So we have taken a random number set of 21 observations. Okay, these are 21 observations. First of all, what we will do is that we will check the distribution. Okay, we will check the distribution of this. So let's check the distribution, as we have already learned it, how to check the distribution. We will have a scatter plot diagram. Now you see, does it resemble something? Okay, yes, this is the normal distribution, right? Okay, now the data is normal, fine, that's okay. Now we have taken the average. Okay, this is the formula for average, and then we have taken the variance. You note that we have taken var.p. Okay, that is the population variance we are calculating. Okay, we are calculating the population variance, and we have taken the square root of this cell, so that is the case of standard deviation, right? Now what we have done is that we have taken random samples. We have taken sample 1, sample 2 and sample 3. Random sampling we have done, and the sample size is 10, so we have taken 10 random, okay, samples. This is how statistical modeling, the basics of statistical modeling works. We have to take the population into mind, and then we draw samples out of the population, and we have calculated the sample mean in all the cases, sample 1, sample 2 and sample 3, and also we have calculated the sample variance. Okay, but in this case we have used var.s. Try to see the difference. Here we have used var.p, here we have used var.s, because we are calculating the variance of the sample. Here we are dividing it by n minus 1. Okay, not n. Okay, remember this. These are the square root. That means the standard deviation. Correct? Now let us see that how close these sample means are with the actual mean, population mean. Okay, this is not close, this is not close, but this is close. We will see a very good fun out here. Okay, now look, this is close, this is close, this is not close, sorry. These two sample 1 and sample 2 are not close, but sample 3 is close. The mean is close. So we can say very well that this is kind of a good estimation of the population mean. And if we look at the standard deviations also, we will see that this sample 1 and sample 2 standard deviation is not close to the population standard deviation, but sample 3 is a little bit closer. But if we now look at the distribution of the sample, now let us look at the distribution of the sample. We will have a now this resembles little bit of kind of a normal distribution, the graph, but not fully. Okay, now let us take the second sample, and this also resembles but not fully, but kind of a normal distribution, you can say. Okay, sample 1 and sample 2 is drawn from this sample, but look at the sample 3. Here the mean resembles the population mean, standard deviation also resembles population standard deviation, but when we look at the graph, what we see, we are unable to correlate this graph with any known graph of normal distribution, right? Now here comes the very fundamental and beautiful part of statistical modeling, that now what to do. This sample has a population mean which is resembling the sample mean which is resembling the population mean. This sample has a variance or a standard deviation which is resembling the population variance, but the distribution of this sample is not resembling any kind of a normal distribution. Now what to do about this kind of things? So these are the important part that we will be covering in our future lectures, and I hope you guys have understood this part that we're trying. Now that we have learned it, we are now going to continue the discussion in the next module. In the next module, we will be talking about variance, covariance, and correlation, and how those things are included in the statistical modeling part. And I hope you are enjoying the sessions. Do write to me so that we can improve upon, we can discuss. Until then, goodbye.